Hi everyone, my name is Dmitry and I'm a solutions architect at Amazon Web Services. Today we're going to talk about getting started with containers on AWS and what benefits you get using the platform to run your containerized applications. Many of you here have probably created many applications before, and you are familiar with the different pieces that go into creating an application. Typically, if you're running an interpreted language, you are going to need a runtime engine. You have your actual application code, and you have any dependencies. For example, if you're using Node.js, maybe you're using npm install. For Python, maybe you're using pip. Often, you have a variety of different dependencies that you need to install for your code to run. And then you're going to have your configuration, which are the values, maybe environment variables, maybe you need to specify how much CPU or memory you are required, and you are going to be using those alongside your code as well. And as a whole, these four components function as your application. But in running your application, there are a variety of different environments in which you need to run it. So, for the local developer, they are developing on their laptops, and we are also having a staging or a QA environment where code is placed temporarily while we test it to make sure that it works. Maybe there is a production environment, and maybe there is even on-prem environment. With all four of these environments, one problem that often arises is that there is a configuration drift or dependency drift or runtime drift across those four different environments. Here is an example of an application which is being developed on a local laptop where the developer is running version 6 of Node.js, and the code runs fantastically. They push it to the staging environment, and on the staging environment, when that environment was set up, it was installed with Node version 7. The code still runs, but then, when the code gets promoted to production, there is a machine on that production cluster that's been around for a while longer, and it's actually running Node version 4, and everything breaks. So this leads to this question of why did it work on my machine, but it didn't work in production? And when you encounter an issue like this, it's very disconcerting because it causes you to lose trust in your deployment lifecycle and whether or not you'll actually be able to deliver an application to your customers. So the solution that's been created to help solve this problem is Docker. The purpose of Docker is to allow you to take your runtime engine, take your dependencies, and take your code and package this up into a consistent unit of deployment. And this artifact that you create as part of your build process is something that you can deliver to any machine. Something that you can run locally, and you will be confident that it's going to run correctly because it's going to bring along with it the proper runtime engine, the proper dependencies, and the proper code. Containers are similar to hardware virtualization, like Elastic Compute Cloud. However, instead of partitioning a machine, containers isolate the processes running on a single operating system. This is a useful concept that lets you use the operating system kernel to create multiple isolated user space processes that can have their own constraints on them, like CPU and memory. The Docker CLI makes using containers easy with commands like docker run. Docker images make it easy to define what runs in a container and versions the entire application. When I actually go and deploy the Docker image, it runs the exact same way on my local laptop. It runs the same way on QA. It runs the same in production. And it runs the same in my on-prem environment. And so I have this confidence that the application I developed on my laptop that worked there is going to work everywhere in exactly the same way where I run it. You may be thinking, this sounds interesting, but why would I use containers? Why builders love containers? There are three benefits of using containers. Packaging. Simple to think about, easy to model out applications, and the component level eases the journey to running microservices. Distribution with better resources utilization. Generally, the container image, which encapsulates everything you need to run your application, is stored in a small, very lightweight, usually tens of megabytes for the image, that can be run on nearly any machine in a repeatable way and utilize resources more efficiently by running multiple lightweight containers per host. And the next is immutable infrastructure. With the packaging and distribution come a simple way to run immutable infrastructure where you can scale up or down very granularly based on requirements. From here, let's start diving a little bit deeper into AWS container ecosystem and introduce Elastic Container Service and Elastic Container Registry and explain how it integrates with the Docker and the reasons why you would use them. When it comes to Docker, running a single host is easy. If I'm working on my local machine, I have a Docker command line application on my machine, and I type docker run and the name of my container, and that Docker container starts up. I can type docker ps to list all the containers running on my machine, and I can see the list. So it's easy for me to launch containers, it's easy to manage them, it's easy to check the status when those containers are on a single host. But running a single host isn't what you want to do on AWS. People use the platform because they want to run a variety of hosts and take the full advantage of the platform and elasticity. They want to run huge clusters of hosts, and we have very large customers that are using Elastic Container Service to solve this problem of how do I distribute my containers across gigantic clusters. So for example, Mapboxes shared with us that they run on 3,500 instances at peak, and we have a customer, Bob Fox, that serves over 1 billion requests an hour using a fleet of 1,200 instances. In the last couple of years, we have seen great adoption of production use cases on Amazon ECS. Our active users are up by more than 450% since 2016, and we are managing containers across millions of instances each month. In fact, we are witnessing an incredible transition to containers and customers scaling on Amazon ECS, whether it's Expedia running its travel platform or the Washington Post running their software as a service platform that consists of more than 100 microservices that composed of more than 3,000 containers. Amazon ECS enables these customers to be able to run containers on large scale. Here I want to share a list of some of our customers, and it's comprised of many companies, from startups to Fortune 500 companies, running tens of millions of applications worldwide on AWS using Amazon ECS and launching hundreds and millions of containers each week. The way to do this is by using a combination of services on AWS. The first one I want to introduce is Elastic Container Registry, because everything in the container world starts with an image. We start with building our Docker images, comprised of multiple layers, and bringing them to a repository. Elastic Container Registry is a fully managed Docker container registry that makes it easy for developers to store, manage, and deploy Docker container images. Amazon ECR is fully integrated with Amazon Elastic Container Service, simplifying your development to production workflow. Amazon ECR eliminates the need to operate your own container repositories or worry about scaling the underlying infrastructure. Amazon ECR hosts your images in a highly available and scalable architecture, allowing you to reliably deploy containers for your applications. Our goal with ECR was to enable developers to use the same familiar Docker push and pull APIs to store their container images. And we see this product highly adopted by customers, both running containers on AWS and really across any environment. When we are ready to run our containers from images that we have in our registry, we move on to Elastic Container Service. That high-level diagram shows the way to start running containers in production on AWS. Elastic Container Service is highly scalable, high-performance container orchestration system. It allows you to easily run and scale containerized applications on Amazon Web Services. Amazon Elastic Container Service eliminates the need for you to install and operate your own container orchestration software, manage and scale a cluster of virtual machines, or schedule containers on those virtual machines. To ensure we can support every workload, we have provided containers running on Amazon ECS deep integration with the breadth of AWS platform features and capabilities to make it easier to run container-based applications in production. These integrations include support for AWS VPC task networking, IAM roles, and security groups for tasks, load balancer support, task auto-scaling, and clusters and tasks, and CloudWatch metrics and logs. We also provide a rich set of developer tools to make it easier to build complex applications on AWS, including integration with AWS Code Pipeline, Code Build, and the ECS CLI, which offers a simplified yet powerful user experience for getting started with ECS. With ECS and auto-scaling, customers can run applications that can easily grow to support cloud-scale applications. So this diagram shows the basic components that go into Amazon Elastic Container Service and how they work together. And I'm going to zoom in on each and highlight each one, explain what it is. So to start with, we have a cluster of hosts running on Amazon EC2, and there are two different ways that you can run on a cluster of hosts. You can run them directly yourself if you want to customize, for example, an Amazon machine image and a fleet of Ubuntu machines with a specific customization. Or you can use Amazon Fargate, which is a new solution for running a container in a serverless manner. You can just give a container to Amazon and say, I would like to run this container somewhere, and Amazon will provision a machine for you behind the scenes without your intervention. I'll talk about this feature in a few minutes. At the lowest level, somewhere, you need a machine to run your container, and whether you are managing that machine yourself or you're using Amazon Fargate, there is still a machine out there. So on that machine, there is an EC2 agent. This agent is what controls what happens on that machine on your behalf. If you wanted to control the machine yourself, you would SSH into it. You would run a command on it, but you don't want to do that manually, especially when you have a fleet of instances. So the ECS agent acts on your behalf. It is consistently running on that machine, and when you want to do something, it does it on your behalf. Launches a container, restarts it, stops it, and fetches stats from it. Whatever you need to do, it will do it on your behalf, without you need to manually go into the machine and do it. And at the top level, there is an API, which is what you use to interact with the cluster as a whole, and you can get really high-level commands to this API. So that, for example, I can say I want to run 4 copies of this particular application container distributed across 3 availability zones, and I want to run them on instances that have the particular type, let's say T3.star. And Amazon ECS will take that high-level command, it will check the state of the cluster that you have provisioned, and it will find ways to play those tasks accordingly on the instances and to fulfill the command that you gave to it. The container task is ultimately what ends up getting placed on the instances when you ask it to run a container. And the task is basically one step above the container. The container is your application, and the task is your application plus configuration about how you want to run your application. So for example, what environment variables does your application need to operate? Does it need disk access? Does it have a port that it receives traffic on? Does it have any particular limits for reading and writing files that need to be set? So the task is where you set all these things about your application container, and the service will communicate with the ECS agent and place the task onto a machine. Amazon ECS allows you to run and maintain a specified number, or as it's also called, desired count, of instances of a task definition simultaneously in an ECS cluster. This is called a service. If any of your tasks should fail or stop for any reason, the Amazon ECS service scheduler launches another instance of your task definition to replace it and maintain the desired count of tasks in the service. The ECS services includes a load balancer and a task definition to publish the exposed ports. A load balancer is configured on your behalf, and ECS takes care of correct traffic routing to the running tasks. But the area we have recently spent a ton of time, based on what we have heard from our customers, is to make containers a fundamental compute primitive. We have done things like IAM roles for tasks, auto-scaling for tasks, and load balancer support for tasks. We took this feedback and have worked hard over the past few years to build a technology that works with Amazon ECS and allows customers to focus entirely on their applications and work with their applications directly at that container or task level and not worry about infrastructure at all. Amazon Fargate is a new technology to run containers without the need to manage underlying infrastructure. Fargate allows you to work entirely with the ECS Tasks native APIs. With Fargate, you specify the container image, CPU, and memory required to run that container in an ECS task definition. And with a single command, you can run that container in production. With one command, you can configure to scale that automatically to tens, hundreds, or even thousands based on your requirements and let Fargate take care of everything else. With Fargate, there are no instances to manage, no more patching operating systems or runtimes. With the new Task Native API, you don't need to worry about clusters. They are there though, as an organization, sort of a logic and security boundary, but you don't need to think about cluster utilization or auto-scaling of compute resources within that cluster. With a resource-based pricing model, you only pay for the resources you provision for each task. We think Fargate fundamentally changes how you think about consumption, how you will run it, and deploy your applications with containers. Let's now take a look at a couple of real-life examples using the components we covered earlier. Let's say you plan to run several highly available applications across 3 different availability zones. ECS enables you to operationalize your containerized workloads at very high scales. No management software to install or worry about its high availability. The cluster management piece enables you to monitor the cluster, scale it using autoscaling groups, and be able to manage state of the instances in the cluster. The placement engine enables you to set rules to target landing your containers on the right instances based on your preferences. And then, finally, the advanced scheduling features help maintain the desired state of the application, spawn new containers to automatically respond to scaling needs, and maintaining resiliency by deploying across multiple availability zones, while being resource-aware of the underlying compute. In another scenario, we see that there are these additional layers of management you need to be aware of when all you wanted to do is running containers. Fargate support for ECS enables you to do just that, fully managed orchestration as well as data pipeline experience, bringing your focus to containers and to your application, not to these multiple moving parts. Let's talk about the rest of the container ecosystem. At re:Invent last year, we announced a new service to help our customers run Kubernetes workloads at scale on AWS. Let's quickly get up to speed with Kubernetes. Kubernetes is an open-source container orchestration system for automated deployments, scaling, and management of containerized applications, and is now maintained by Cloud Native Computing Foundation. It's a very popular system, and the interest to it in a community grows at a rapid pace. A lot of our customers asked us about a service that will help them to run Kubernetes workloads at massive scale in production without spending time on managing all its components and moving parts. We listened, and that's why we have built Elastic Container Service for Kubernetes, or EKS. We know how important a well-functioning service is to our customers. There are a core set of tenets that we followed which guided our decision-making for how Amazon EKS should work. Let's talk about the tenets that underpin our design decision for EKS. EKS is a platform for enterprises to run production-grade workloads. EKS aims to provide features and management capabilities to allow enterprises to run real workloads at real scale. Reliability, visibility, scalability, and ease of management are our priorities. One of the areas where we are putting in a lot of effort is to availability. By default, AKS is multi-master. We run masters across multiple availability zones, and we manage your persistence layer for you. AKS provides a native upstream Kubernetes experience, and modifications or improvements that you make in our service must be transparent to the Kubernetes end user. This means that your existing Kubernetes experience and know-how applies directly to AKS. Your existing applications and investment in Kubernetes work right out of the box with AKS. AKS customers are not forced to use additional AWS services, but if they want to, the integration is seamless and eliminate undifferentiated heavy lifting. We are focused on making contributions to the projects that allow customers to use the AWS components they currently know and love with their applications in Kubernetes. The other thing our customers care about is integration into the rest of AWS, and this is another area where we plan to focus and contribute upstream. And the next tenet is that the AKS team actively contributes to the Kubernetes project to improve the Kubernetes experience for all AWS customers. Now, with AKS, the complexity of standing up your own Kubernetes control plane is simplified. Instead of running the Kubernetes control plane in your account, you connect to a managed Kubernetes endpoint in AWS Cloud. The endpoint abstracts the complexity of the Kubernetes control plane. Your worker nodes can check into a cluster, and you can interact with your Kubernetes cluster through the tooling you already know and love. Here, I just want to show the AWS container ecosystem on one picture and the very high-level flow of starting with running containerized applications at scale. You start with choosing an orchestration tool, and then make a choice of the launch type. And the beauty here is that launch types are backward compatible, giving you the flexibility and power of running applications in a coexistence mode. Let me recommend a few resources where you can find great workshops and guides for you to go ahead with building your containerized applications on AWS. These hands-on workshops and guides walk you through all the main bits and pieces you would need to run containers at scale on AWS. Thank you, and keep on building.